Welcome back to my channel Math School. In today's video, let us solve part 6 from question 1, exercise 3.6, chapter 3, pair of linear equations in two variables. In my previous videos, I have completed the example problems, exercises 3.1, 3.2 and 3.4. If you have not watched these videos, do find the link in the description box below or click the I button above. So now quickly let us begin with the video. Part 6 from question number 1, exercise 3.6, chapter 3, pair of linear equations in two variables says, solve the following pairs of equations by reducing them to a pair of linear equations. So these are the two given equations. We have to reduce them we have to reduce them to a general form of a pair of linear equations. General form of a pair of linear equations is given by a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. So here in the given equations you can observe that the constant which is on the right hand side also has the xy term, right? But the constant should be only the coefficient without any variable. So first we have to remove this xy term from the constant on the right hand side of the given equations, right? So for that, let us write the given first equation as 6x plus 3y equal to 6 into xy. Now let us send this xy to left hand side. Since it is in the numerator, it comes in the denominator on the left hand side. So it comes in the form 6x plus 3y divided by xy equal to 6. Similarly, let us do for the second equation, which is given as 2x plus 4y equal to 5xy. So 5xy can be written as 5 into xy. Now send this xy term to left hand side. So we get 2x plus 4y divided by xy equal to 5. Now let us separate this denominator xy so that it becomes 6x divided by xy plus 3y divided by xy equal to 6. So here x and x get cancelled. Similarly in the second term, y and y will get cancelled and we will be just left with 6 by y plus 3 by x equal to 6. So let this be equation number 1. Similarly here we can again separate the denominators for both the terms. So this will become 2x divided by xy plus 4y divided by xy equal to 5. Here again x and x will get cancelled in the numerator and denominator. Similarly y and y term will get cancelled. So we will be left with 2 by y plus 4 by x equal to 5. So let this be equation number 2. So here again if you observe in equation 1 and 2, the variable is again in the denominators, whereas for the standard form of a linear equations, the variables should be in the numerator always. So to bring this variable to the numerator, let us substitute here 1 by y and 1 by x to some other variable like p and q. Okay, so write down let 1 by y equal to p and 1 by x equal to q. So here from first equation we can write 6 into 1 by y will be p. So this will be 6p plus 3 into 1 by x will be q. 3q equal to 6. So let this be equation number 3. Similarly from equation 2 if you substitute 1 by y equal to p, so this will be 2p plus 4 into 1 by x as equal to q, 4q equal to 5. So therefore this will be equation number 4. You can further reduce this equation 3 if you take from 6p and 3q 3 outside as common. So this will be left with 3 into 2 is 6. So 2p will be left, and if you take 3 common from here, q is left equal to 6. So if you send this 3 to right hand side, 2p plus q is equal to 6 divided by 3. So what is 6 divided by 3? 3 1 times, 3 2 times. So this will be equal to 2. right? So let this be equation number 3. Now we have obtained two equations, that is equation 3 and 4, where you can observe that the variables are in the numerator in both the equation. Therefore it is in the standard form of a pair of linear equations. Now for this equation 3 and 4, let us apply elimination method and solve these two equations and find out the x and y value. So write apply elimination method to equations 3 and 4. So from equation 3 we have 2p plus q equal to 2. From equation 4 we have 2p plus 4q equal to 5, right? So to apply the elimination method, we have to make sure the variable we are going to eliminate must have the same coefficient. So here the p variable has same coefficient, that is 2. Therefore we can eliminate the p variable, but the signs should be plus and minus. Here we have both the signs are plus. So let us change the signs for the second equation. So this plus 2p will become minus 2p, plus 4q will become minus 4q. Again we have here plus 2 and plus 5. Here plus 5 will become minus 5, right? So this plus 2q and minus 2q will get eliminated or cancelled, and we will be left with plus q and minus 4q. So subtracting 4 minus 1, we get 3q with a greater number sign, that is minus, equal to, again we have plus 2 and minus 5. So we have to subtract 5 minus 2 is again 3 with a greater number sign, that is minus 3. So we get minus 3q is equal to minus 3. This minus and minus will get cancelled, or q is equal to 3 by 3. So 3 and 3 will get cancelled and we will be left with q equal to 1. Now let us substitute this q equal to 1 either in equation 3 or equation 4 and find out the p value. So write down substitute q equal to 1 in equation 3. So from equation 3 we have 2p plus q equal to 2. Therefore we have 2p plus q value is 1. We have to substitute equal to 2. So send this 1 to right hand side, we get 2p equal to 2 minus 1. So 2 minus 1 is 1. So 2p is equal to 1, or p will be equal to 1 divided by 2. So we got q as equal to 1 and p equal to 1 by 2. But initially we had assumed p as equal to 1 by y, right? P as equal to 1 by y. So let us equate right hand sides of the p, since the left hand side is equal. So we get 1 by y is equal to 1 by 2. Cross multiplying, we will get 2 into 1 is 2 is equal to y into 1 as y. So therefore we get y is equal to 2. Similarly, now we got q as equal to 1, whereas initially we had assumed q as equal to 1 by x. So equating right hand sides, we get 1 by x is equal to 1, or cross multiplying x into 1 will be x equal to 1. So we got x is equal to 1 and y is equal to 2, which is the solution for the given pair of equations. So therefore you can write down x equal to 1 and y equal to 2 are the solutions for given pair of equations. This is how we solve this problem. If you have any further doubts, do comment me below in the comment section. In my next video, I'll be solving part 7 from question number 1, exercise 3.6, chapter 3, pair of linear equations in 2 variables. So till then, do like my video, subscribe to my channel, and don't forget to hit the bell button below to get the latest updates of my videos, as I'll be completing the whole syllabus for class 10th SLC NCERT math. And also do watch the related videos of chapter 3, pair of linear equations shown on the screen. Thank you.